Good morning once again. Yeah, we will start from like yesterday, where we left yesterday. From that point itself, we will start. So yeah, we were discussing this second part, which is nothing but self-supervision, bird and beyond. So, yeah, three notebooks were there. We had seen the first and second. First, exploring the data, and second, text classification. Now, next one is this third one, NER, named entity recognition. Let me increase the font size. Here we have seen this text classification stuff. Click run all cell. Just a quick review of the second notebook, because the assignment is completely based on the second notebook. It was Nemo overview. Two parts were there, that lightning module and trainer module. Then every Nemo model has two things. First one is that configuration file and training script. These are all various files. Here we need to work upon that text classification model. This is the YAML file of text classification, and this is nothing but that Python script. Next one, it was the preparation of data. Yeah, that header row that we want and should be removed. And we have seen that how to remove this header row. Yeah, by using this bash command. Then we had this configuration file, file directory plus configuration file. Here we would be exploring that what is there inside this configuration file, but to open this with the help of Omega Conf tool. So this is what we were. Three categories were there, like first model category, second trainer category, and third experimental manager category. So here we would be exploring model category, then trainer category, and then third one experimental manager category. So this was the task which was given. We need to change this number of classes of data set of model to 3, maximum sequence length of data set to 128, like that. Fine. Then some exercise was there. Here we need to change that AMP level precision. Here this was the solution. And yeah, then we can visualize the result on TensorBoard. Then here next task was like changing the language model. So here we have seen that how can we change the language model also. Fine. Now we start with which is nothing but building NER, like named entity recognizer. Here exactly most of the things would be same. Like previous task was there, text classification. Now this is nothing but NER task. Here we need to see how can we do the token classification. This is not text classification, it is token classification. So suppose one paragraph is given, so we need to identify what is the token type of first token, what is the token type of second token, like that. So this is nothing but classification at token level, not classification at text level or paragraph level. Okay, that's why it is called token classification. Then here some data inputs are there. After that, IOB tagging, then configuration file already seen in the context of that previous notebook, which is text classification. Fine. uh, it is mentioned that for any text classification task built to project, train it as the same methodology that we would be following over here. Here we can also see like domain specific BioMegatron language model. BioMegatron is just BERT like model, which is nothing but Megatron LM model. Experimentation, we are working on that NCBI disease corpus, which is nothing but the medical text corpus. So it would be better like if we work on some pre-trained model, which is pre-trained on medical corpus. Fine. Then we will see that various models available. So yeah, this is the model that we are interested in, token classification. This is the model token classification. Then next we are having inputs. So this is my working directory. In this data folder, NER3 is the working directory, and these are all files there. Just print all these files. Test and label. So if in disease name, for example, if we need to extend it to part of speech analysis, okay, and our job is to identify the noun and to identify the verb. Then here, how many tags are required? See here, uh, we need to differentiate between verb and noun also. Beginning, we should have some meaning of verb, and then outside means outside. Right? So total 5 tags would be required. This type of questions are there in the MCQ. It is my working directory. This is my conf folder, and here the working configuration file is there. And we are interested in this token classification train.py. It is the training script. Now, once again, we are importing that Omega Conf tool. So this is what we are doing. This is my configuration directory, and this is my configuration file. Okay, concatenating both of these and exploring the model parameter here. See, this config.model is nothing but the model parameter, right? Then there are various models available there. Megatron BERT 345 million uncased, Megatron BERT 345 million cased, Megatron BERT uncased, like that. Okay, all these are the models, pre-trained models.
Sir,
We can use any one of these.
sir,
Yes.
looks like the screen is not shared.
Now it is fine.
Yes, sir.
So yeah, just like what we were looking, this text classification. These were the various models. Then these are the various files available for NER dataset like NER3. This is IOB tagging. Yeah, I was explaining this. For example, I need to differentiate that verb and noun also with the help of IOB tagging. Then I should be having 5 tags. Uh, it is not required that to have 6 tags. For example, beginning of noun and beginning of verb is fine. Inside of noun, inside of verb is fine. But outside of verb and outside of noun, so they should not be 2 tags. Outside means outside, irrespective of whether it is outside of noun or outside of verb. So here 5 tags would be required. Next, this was the configuration file. This is my directory, and here we are exploring this. This is my config folder. This configuration file that I need to explore, and this is nothing but my Python script. So here, this is the configuration directory, then configuration file, then loading this like concatenation of both of these and loading the model parameters over here. These are the model parameters. Various models are available over here. Look at this. These are the models. We can use any one of these models like pre-trained models. Then next one, like loading the trainer configuration. So these are nothing but the trainer configuration, GPU, number of node, max epoch, etc. Lastly, we would be having experimental manager configuration. So here, basically, we would be working on 2 Python script. One is that token classification, train.py, and token evaluate.py. Encapsulate everything needed to run a token classification experimentation defined by the configuration file. Once again, we need to use this Facebook Hydra tool for data management. So here we need to set this like pre-trained model name. We need to set it to BERT base case model. Fine. Pre-trained model name is a parameter which belongs to language model. Language model comes under model category. Similarly, data directory of data set, then maximum sequence length of data set, batch size of all these train DS, validation DS, and test DS is set to 32. AMP level we need to set it to O1 and max epoch is 3. We can also refer the solution. We first need to define that token directory, and here all these variables are defined. After that, we need to run the Python script, and we can override these parameters just like this. Model dot language model dot pre-trained language model is equal to this variable pre-trained language model. It is written as dollar pre-trained model name because this is simply a variable. When we are using this in our Python script, then we should use this dollar symbol. These are the result part. Next, it was domain specific training. We can run this. We are running it for 3 epochs. This is epoch number 0. Here we can see precision and recall. Then next epoch is started. Fine. So this is the result. Next, we need to do it for domain-specific training. So in pre-trained model name, if we are using this Biomegatron BERT 345 million case parameter, then we see here we are just changing this name Biomegatron BERT 345 million case parameter. Just run this. See here the number of epoch and all other parameters are exactly same. The only difference between this and this is that here we are using uh, this pre-trained model name, which pre-trained model, which is nothing but Biomegatron BERT. This is domain specific model, like domain, like medical domain related model is there. So definitely it should perform better as compared to the nav one. It's a larger model, that's why it is taking time. Okay, so here we get the improvised result when we are using domain specific model in all the contexts, like for example accuracy, precision, recall, etc. In all of these. So we can also visualize the result on TensorBoard. Okay. So next part is nothing but the evaluation. We have another Python script on which we can like evaluate the trained model. Fine. Here I am stopping this second task and I am starting the third one. Not exactly third one, but this assignment part, the coding assignment. Now we need, so simultaneously you can also load the assignment. First we will try to understand that assignment, then we will see like how we can submit or how we can solve the assignment. I will not give the exact solution to the assignment, but definitely I will give you some hint. Based upon that, you can complete the assignment. Meanwhile, if any query is there, then we can take some queries. Okay, so this assignment is loaded now. See here, we can see this launch button is there. You need to click on this launch button, then stop task is there. After that, this assist task is there. Right? Now we will try to first understand the assignment. This is nothing but the assignment. The title of this assignment is authorship. Okay, so this assignment is loaded. You can see here three buttons are there: launch, stop task, and assist task. We just need to click on this launch button. So this is nothing but that assignment. The title of this assignment is authorship attribution. Basically, which type of problem is this? Authorship attribution is a type of text classification problem. Instead of categorizing text by topic, okay, here we just need to find out the like what we did in disease text classification problem. The objective here is to classify the text by author. For example, we are given some paragraph or some document is given. We need to identify or we need to categorize this based upon the author, whether it belongs to author 1 or author 2, like that. Now these are nothing but the table of content. First, the problem is there. Then step one is nothing but the preparation of data. Step two is a preparation of model configuration. Then step three is nothing but preparation of trainer configuration. After that, step four is there, train. Step five, inference, and lastly, submit the assignment. So this is nothing but the table of content. This is the problem. Federalist paper history mystery. Here it is a set of like essay written between 1787 and 1788 by three authors, Hamilton, Madison, and John Jay. Initially published under this, their intent was to encourage the rectification point. So this is all about related to this problem. A list emerged where author of each of these 85 papers were identified. As a subset of these papers, the author is still in question. Fine. So now we will try to solve this BERT based project. In concrete term, the problem is whether it belongs to Hamilton or belongs to Madison. Fine. So no collaboration is there, like no joint writing is not there. It is solely belongs to one of. We are having this data set, for example, trend. So this is my data folder. In this Federalist paper HM is there. So in this my train.tsv, dev.tsv and all test files are there. So this is nothing but train.tsv. We can just click this train.tsv. Similarly, we are having this another file which is nothing but dev.tsv. Here, like sentences are given. For example, look at this. This type of data is there. These are the sentences, or we can say the paragraph is there. The entire paragraph belongs to this author. Fine. Each sentence is actually a group of sentences of approximately 256 words. The label 0 is used for Hamilton and 1 is used for Madison. So here we can see this label 0 means all these title were written by Hamilton. So total, look at this. This is the data. Look at this. It is an example of imbalanced data. Approximately 366 out of total what? Out of 500, like 350 we can say belongs to Hamilton and only 150 belongs to Madison. So we can say that like 30% belongs to Madison and 70% articles belonging to Hamilton. So it is an imbalanced data set. This is my development or validation set. Here also majority belongs to Hamilton, 89 you can say 90 and 115. Here also around 70% data belongs to Hamilton, and 30% data belongs to Hamilton. Why I am explaining this? Because uh, the distribution, like the data distribution in training and development set, should be same. The distribution should be same. For example, here see 70% belongs to Hamilton and 30% belongs to Madison. Same 70% or approximately 70% should belongs to Hamilton and 30% should belongs to Madison in the development set also. Otherwise, it should not be like that. You are training the image, you are training your model on very clear images, and you are validating it on some blur images. If there is a change in the distribution from training to development, then there is a possibility that the model will overfit. Model will not perform well on the unseen data. The generalizational capability of the model will suffer. Okay. So you just need to remember 0 is for Hamilton and 1 for Madison. Yeah, here we need to refer this notebook number 2, which we just studied, that text classification and NER. And this is nothing but the scoring. Here we can see like preparation of project. Here two fixed me's are there. Per fixed me we are having 5 points, so 10 points. Then preparation of model configuration. So 3 fixed me's are there, so it is 15 points. Then preparation of trainer configuration, once again 3 fixed me's, so 15 points. And then train is there. 4 fixed me's, 20 points. Yeah, we need to use this text classification with bird.py. Which model I am using? I am using the text classification model. In that text classification, one configuration file would be there and one Python script would be there, right? These are the various resources and hints. For example, which reference notebook that we should use for solving this assignment, just as just for hint and other purposes. So notebook number 2 of second part. Then pre-trained model name. Which pre-trained language model we should use? So we need to decide carefully. For example, if we take any uncased model, so there might be a possibility that the writing style of author, uh, like we can say some author can write in uppercase letter, some author may prefer to write in lowercase letter. So definitely, if the model is cased one, like if the model is capable of differentiating uppercase and lowercase, then it will help us in identifying the author. Fine. So we should use the cased model. We should not use uncased model. Then, depending upon the size of the model, we should first define like maximum sequence length. It can be 256 also if the model is like if the small model is used, or otherwise if it is a considerable size model is there, then we should just reduce it from 256 to 128. And if the model is very large, then we can use 64 or otherwise 32 also. This is nothing but the maximum sequence length. What is the significance of maximum sequence length? That initial these many words are used and remaining text are simply ignored or discarded. It is nothing but maximum sequence length. Number of classes, we know that only two classes are there. One is used for Hamilton and two is used, sorry, zero is used for Hamilton and one is used for Madison. Now batch size, what should be the batch size, whether it is 16, 32? It should be clearly accommodable in the memory usage. We should not get this error like runtime error put out of memory. If you get this kind of error, it means that we are not able to accommodate all these things into memory. Which all these things, like the model, these many samples in the batch, the maximum sequence length. Okay. If the model is very large, then we should reduce the maximum sequence length. We should reduce the batch size. So we should have proper relation between the model size and batch size and the maximum sequence length. Then we need to get the accuracy and loss. So it is definitely possible to achieve 95% accuracy. Our assignment will be successful only when we should get 95% or more accuracy. Then number of epochs that we need to decide. So if we are training it for only 2 or 3 epochs, then we may not get the expected result. So we should run it for at least 5 epochs like that. Now the first step, preparation of data. Now look at this. We just need to see is there any fix me in this cell? If not, then simply we need to understand the cell and we need to run this. Fine. So here we are importing these things. No fix me's are there. Here we are simply importing what utilities which are required for auto grading. For running the cell, the command is shift enter. You can also solve this. Now this is my data directory. Yes, this is a data directory, and what is there inside this data directory? All these files are there. But how the files are distributed? One train file is there, like one training file. Second, one validation file or development file is there, and 10 test files are there. So here we can see first test file, second test file, third test file, like that. Total 10 test files are there. Now data formatted, it is graded. Here the data is not in the correct format for NEMO classification. Can we see the data? Yes. What should be the problem with data? Again the same problem, like the header row should not be there. We need to remove the header row because NEMO does not expect the input with header row. So that header row should be removed. Correct the data. This is our task, like correct the data and save the new data set in this directory. Yeah, again in the same directory with this name, like train nemo format.tsv and dev nemo format.tsv. So how can we do this? We are having the previous notebook open with us. We can go to this text classification part. Okay. See here. So I just copy all these things from here. I can just paste it there. Now just tell me what changes should I make over here. See, correct the format for train and test development. Correct the format for train and development. Fine. It is mentioned that you do not need to do anything with any of the test files. So the third line should be removed from here. Third line is removed. Fine. Now, what is the name of my directory? Here I must have defined the name. The name is data dir. The name is data dir. So here TC3 is not there. The previous notebook that we were using, The name of this directory is tc3, but here tc3 is not there, so I need to remove this tc3. The file name is data dir, right? Here also data dir. Then like that, then simply run this. Fine. After that, what we need to do, we need to just verify that whether we have run these things successfully or not. Whether we have removed this. So here we can see two files should have been generated: dev nemo format and train nemo format. Fine. So we will see some of the initial sample from both of these. So here we can see first one is this train nemo format.tsv. Here that header row is not there. Fine. After that, this is what run to save for assessment. Do not change. Okay. So no fix me's are there. Simply we need to run this. Fine. Any doubt in step one? Any doubt? Have you completed the step one, all of you? Fine. Next, we will have a look at like preparation of model configuration, preparation for the model configuration. So this is my configuration directory and this is my configuration file. We need to concatenate both of these. Okay, so this is nothing but our configuration file and loading the model parameter of this. Then we are having various models available. These are the various models. Then this is nothing but the graded one. Here we need to define like maximum sequence length. So sorry for number of classes. So total two classes are there. Either it belongs maximum sequence length. We can take 32, 64, 128, 256. So safer side we can take 120, which is somewhere in the middle of all this. Batch size I will take 16. Now run this. So number of classes I have taken 2, maximum sequence length I have taken 128, batch size I have taken 6. Then word base uncased is this pre-trained model. So fine. And then last one this. Then we are printing the trainer and experimental manager configuration. Then for how many epochs we need to train, just let me put it 10. Then AMP level, I should use that automatic max precision. So this is O1. Make sure that it is not 01, it is O1. Precision, so I just perform 16-bit arithmetic. So this is my precision, and then save. Then next one is this. Here I am just running this Python script, text classification with word.py. I have defined number of classes, maximum sequence length, path to train and validation files, and sample inferences, max epoch, etc. Pre-trained model name. The things which are not defined over here, are nothing but the fix me that we need to fix. Which are the things which are not defined? Look at this now. Precision, AMP level, and max epoch. All these are defined. Precision, AMP level, and max epochs. So max epoch is defined, but precision and AMP levels are not defined. So I need to define here precision and AMP level. I should know that this parameters like precision and AMP level comes under trainer. So trainer dot precision is equal to what? What is the that I have used here? Precision is this. Just copy this precision. Then next, it is once again trainer configuration. Trainer dot AMP level is equal to dollar AMP level, automatic mix precision level. Fine. So precision AMP level, both the things, and maxipok is also defined. Now go precision, maxipok, and AMP levels are defined. Now go next. Here see learning rate and pre-trained model name. Learning rate and pre-trained model name. So learning rate is also not defined here. Learning rate comes under model dot optim dot lr is equal to $lr. Then pre-trained model name that I have used here. File path to training and validation they have defined. Pre-trained model name, path to train, and batch size, maximum sequence length, and number of classes. Batch size, maximum sequence length, and number of classes. Number of classes is defined, maximum sequence length is defined, but batch size is not defined. So here I need to write the batch size. How can I write the batch size? I can take help from the second notebook also. Here somewhere I might have defined that batch size. Look at this. How can I define this batch size? So batch size for training and validation both. Mod batch size is this. Batch size comes under training dataset. Training dataset comes under model. So here I need to write this one. Make sure that the indentation is proper. Model dot what is the next one? This is validation DS. Validation DS and then batch size. This last backslash would not be there. Fine. So we have defined all these things. Now we need to run the Python script. Just run this Python script now. So I'm running this Python script. We'll check the results. Okay, now it has run. See the outcome. This is nothing but the precision and recall that we are getting. We are running it for 10 epochs. Next. Here no fixed me's are there. Simply we need to run this. Then infer. We need to check it on the test files. So these are my 10 test files are there. No fixed me's are there. Simply run this. Then next one is this. I am just printing the outcome. So here we can see 10 test files are there. This is the model prediction. For 5 it is saying that it is medicine, and for next 5 it is saying that it belongs to Hamilton. See, what is the correct answer? Correct answer is that uh, all test files belongs to medicine only. All test files belongs to medicine. If you get this answer, or at least 9 files should belongs to medicine, uh, then only you can go to this first part, click on this assess task button, and then only your certificate would get generated. Fine. So which are the changes that I can perform over here to improve the results? I can change the model. I can change the model over here. See, this was the uncased one, but it is there. It is also already there in the hint part that it should be cased one. Just rerun this. The rest of the things just put as it is. Okay. It is a case model. So in comparison to the uncased one, it takes some larger amount of time. Okay, so it has run now. Just look at this, the results. Then this is fine. Here, once again, we are not getting any improvement in the result part. Again, only 3 medicine and 7 Hamiltons are there. Now what we will do? We need to try some other model. We need to try some other model. Which are the various models available here? So we can try this large model, but large cased model. Let's look at this now. Yeah, this one. Just change this. Here I am writing large model. One error is there, like getting error in cell 15. So what is cell 15? No, just put the like step, in which step you are getting the error. So we just need to see one or two stuff over here, like how the model is represented after deployment. Exporting the model is the things that we are interested in looking. So here we will be looking at optimization and performance, then BERT checkpoint, then testing our export, and beyond torch script. There are various model format in which we can export the model. For example, in various model formats are there in which we can export the model such as PyTorch, JIT or Torch script. Then Onyx runtime is there, Onyx TensorRT and TensorRT. All these are nothing but the PyTorch based model format. How can we export a checkpoint? For example, here, look at this checkpoint. Here, this is nothing but the BERT question answering checkpoint is there. Some helper script is there, which is already written for us. For example, checking whether Triton server is live or not. Then next one, developer.py is another Python script which is used to convert a checkpoint into deployable model and export it. Finally, some measure performance with performance analyzer application, and some warm up SH is there, which just run some inferences using this performance analyzer. Here we would be working with Triton, NVIDIA Triton inference server. Basically, this Triton is available on port 8000. Okay, so this is nothing but the Triton, and just here we will see whether it is ready or not. So which utility I need to call? This one, first one, server Triton server.sh. It is just checking whether Triton server is ready or not. Then it is nothing but the model repository. Model repository is one working directory. All these models should be there in this directory only, so that Triton can see this model. For example, see, this is nothing but the path. So here first model is there, then second model. All these models will be available there. And if the model is available in this folder, then only Triton can see it, otherwise not. So here in each of these model, we are having one configuration file. Some other informations which are stored in this configuration file is that, yeah, we will see this. Now first is torch script export. So we are interested in first uh, format, which is nothing but torch script. So here, which model I am taking? This is nothing but my BERT question answering torch script model name. And here I am running this developer.py. What is the task of this utility? It convert a checkpoint into deployable model and export it. Fine. The deployer.py script load this checkpoint, deploy it in this format into a folder, this folder like BERT QA torch script, and mark as it as version 1. Fine. So here two things are there. First one is this BERT QA torch script, and second, in that one is there. Exactly same thing is there into that also. Now, if we look at this config file, like config.this, What is there inside this config file? This is general model serving configuration. What is the name of this model? Which platform it usage? What is the batch size? What is the input and expected output size? So this one, input and output. Then which are the optimization that are used by this, and what are the instance group? So these informations are available in the that configuration file. Yeah, it is mentioned there. The configuration file is fairly simple and define these many things. Now next we need to move this into model repository, because as I told earlier that all these models should be there in this model repository only. Fine. So we are moving this torch script into this model directory. Once it is imported or once it is moved from this folder to model repository, now we can just test whether Triton can see this or not. Okay. So here we are just defining all these things like precision, batch size, max latency. Here max latency is important, this 500. Just remember this. After that, we are having this model name is equal to this, max concurrency is 2, and running this performance analyzer. Fine. See the result now. If everything went okay, you should have been presented. Fine. So this type of outcome should be presented. Fine. It is running perfectly. Waiting for Triton server to be ready on this port. Triton server is ready, and after that is printing this. First request concurrency 1. Here max concurrency is 2. So basically first is expecting that request concurrency 1, and then in each concurrency we are just printing throughput and latency. Throughput means what? Like we can say that how many inferences can be drawn per unit of time. So this is nothing but throughput, and latency means uh, like for how many times or for how much time one particular inference has to wait to get it processed. So this is nothing but second one. Here we can see pass 1, pass 2, pass 3, pass 4, and after that this is the request concurrency 2. Fine. This was which format? Torch script. Now beyond Torch script, we are having some other formats also. For example, ONNX. ONNX is an open source format for representation and exchange of neural network model. Full form is Open Neural Network Exchange. It is called ONNX. So this time we would be importing the model in this format. So here I am writing BERT Q&A ONNX. Export format is ONNX. Now this time we are running the developer.py script over here. Once again that now this script is loaded here. After that it is converted into deployable model and exported. Fine. Using this deployer.py, and once again we need to perform the same thing. This is what we are doing, exactly same thing. Then we need to move this model into that model repository, and once it is deployed into that model repository, then we need to run this. Like Triton server can see this now. It will take some time to run. Now format is ready. We have a couple of options for executing ONNX based export in Triton. We can take advantages of ONNX runtime, and we can ask TensorRT to parse this ONNX asset in order to generate a TensorRT engine to use instead. Okay, so two options are there. First, we need to export this into model repository. Fine. See, this is the results. Here, actually, what we need to look, the maximum latency that we have defined as 500 millisecond. After this 500 millisecond, it got interrupted and stopped execution. Fine. So here, this is the question: like, did we manage to run our benchmark at all 10 concurrency level? No, because after this 500 millisecond latency, it got interrupted and stopped the execution. Let's look at this. So this is the outcome. We run it for 10 concurrency level, but here we can see this is concurrency 1, concurrency 2, concurrency 3, and concurrency 4. After this, it is below 500 millisecond, but after that it crossed to 500 millisecond, then the like it is aborted. After that, it is not executing. So we are able to manage only 4 concurrency level. Now next, this is the ONNX TRT floating point 16. This is another format, ONNX format. Once again, we need to do the same thing. Then next, we need to enable the TensorRT optimization. So we have seen that optimization was there in that configuration file. So in that configuration, we need to put the optimizer name. So if the optimizer name is that TensorRT, then all the optimization corresponding to TensorRT can be applied there. Here optimization is presented like this: execution accelerator, and this is nothing but the GPU execution accelerator. Here the name should be placed as TensorRT. So this TensorRT optimization can be applied there. For example, it can be any quantization or any other stuff which can be done after uh, deploying the model. So we need to modify this file. Just open this file. Look at this file. Optimization is there, and this is nothing but the solution.
Solution. Other
And and then save it.
Itu baru mau
So that Triton can see this. Now just run this. This time we can see when we are applying this TensorRT optimizations, then it is able to manage all the concurrency level. So previously when we were working upon like with the help of simply ONNX without TensorRT optimization, then it was managed only for concurrency level. But when we applied this TensorRT optimization, it is manageable for all the concurrency level. Here we will see the results. So this is all about like how the model can be exported, how the model can be converted from that checkpoint to a deployable model, and there is one specific format of the deployed model. So we can use this for very different types of formats are there. For example, Torch script, ONNX is there. On top of this, we can apply several sort of optimization such as TensorRT or any other optimization. We can apply that GPU instance is equal to 2. In that manner, what would happen? Like multiple instances of the model can run in parallel. So all these are nothing but the optimization that can be applied later on. Here we can see this is nothing but the configuration file. It is the instance group, right? In this instance group, if it is written count is equal to 1, it indicates that only one model instance can run at a time. But here it can be changed to 2. It indicates that 2 instances of the same model can run in parallel. Yeah, and what is the effect? Effect is nothing but the improvisation in latency and throughput. This is what all we can done on this. So this was related to deployment of the model. Fine. Just we need to make sure that request concurrency 2, 3, 4, and after that request concurrency 5th can be manageable or not. Here we can see now all the concurrency levels are maintained because it is coming under 500 millisecond. This is just because that we introduced what? We introduced this optimization in the configuration file. And what is that optimization? This TensorRT optimization. So this was all about the optimization and deployment part. Any query or any doubt? So we can stop over here. We will start with the prompt engineering in the next session.